Hello guys, welcome to today's class. So today we'll be looking at finding still from first principle, how to use first principle to derive the general formula on solving differentiation. So but first of all, we'll be looking at how to find derivative of a constant. So the first question says find the derivative of y equals to c when c is a constant from first principle. So you see that y is equals to c. And wherever you see y, put change in what? Y. So remember that y is what? C is what? A constant. So you can say that y plus change in y is equals to c. Don't forget that since c is what? A constant. So there's nothing like change in c. C is a constant. So we can say that change in y is equals to what? 0. And change in y over change in x is equal to 0. So if we take the limit when change in x approaches 0, change in y over change in x is still equal to what? 0. So you can say that dy dx is equal to 0. This proves that whenever you differentiate a constant, you get what? 0. Whenever you differentiate a constant, you get 0. The derivative of a constant is what? 0. So now let's take another example that says that find from first principle derivative of y equals to derivative of y equals to ax plus b, where a and b are what? Constant. A and b are constant. So you can say that y is equal to what? Y is equal to ax plus b, y plus change in y is equal to a, all in bracket, x plus change in what? X. Remember that a and b are constant. So the variables that are not constant requires the change in. So plus what? B. So this is equal to ax plus a change in b, a change in x plus b. This is equal to y plus change in y is equal to ax plus a change in x plus b minus ax plus b. Remember, y is equal to ax what? Plus b. So there's supposed to be minus y here. So if you minus y from both sides, you take minus y plus change in y minus y. Remember, y is equal to what? Change in y is equal to ax plus b. So at this other side, you put minus ax plus what? B. So we can say that y, this y we cancel this y. Well, let me write it for better understanding. I will say y plus change in y minus y is equal to ax plus a change in x plus b minus ax plus b. Now this y will cancel this y, so we are left with change in y equals to ax plus a change in x plus b minus times ax give you a minus ax minus times plus b give you a minus b. So we have change in y to be equal to minus b will cancel plus b. This will cancel this. So we are left with a change in x. So if we divide both sides by ax, by changing x, we are left with change in y over change in x is equal to what? A. So we can, if we take the limit when change in x approaches 0 of change in y over change in x is still equal to a. So therefore, we can say that the y dx is equal to a. So now henceforth we find the derivative using first principle of y equals to ax plus b. Remember, a derivative of y equals to x raised power n. So if we find this derivative using first principle, this will lead us to a formula called the general rule. It's called what? The general rule. So the question say y equals to x raised to power n. So we say let y be equals to x raised to power n, and y plus change in y is equals to what? X plus change in x raised to power what? N. So now, if we expand this using binomial theorem, we have x raised to power n plus n x n minus 1 change in x plus n in bracket n minus 1 divided by 1.2 x raised by n minus 2 times change in x square plus change in x raised by what? N. So if you use binomial theorem to expand this is what you will get. So on maybe on our subsequent class, I'm going to expatiate more on binomial theorem. Binomial theorem. So if we minus y from both sides, we say that y plus change in y minus y. And remember that y is equals to changing. Y is equals to x raised power n. So if we minus x raised power n from this side of the equation, the x raised power minus x raised power n, we're going to cancel out this. And this y will cancel out this. So we are going to, okay, let me show it. This equals to x raised power n plus n x n minus 1 change in x plus n in bracket n minus 1 divided by 1.2 x raised to power n minus 1 n minus 2 times change in x raised to power 2 plus change in x raised to power n minus x raised to power n. So this we cancel out this as y plus y cancel out minus y. So we say that change in y will now be equal to nx n raised by minus 1 change in x plus n minus 1 divided by 1.2 x n minus 2 times change in x square plus change in x raised by n. So now, if we divide both sides by x by changing n, we divide both sides by changing n, we are going to have that change in y over change in x will be equal to so if we divide both sides by changing x, our result will be n x raised by n minus 1. So changing x will cancel out the change in x here. So we have only n x raised by n minus 1 plus the change in x plus n bracket n minus 1 divided by 1.2 x n raised by minus 2 minus 2 times change in what? X. So now we can take the limit when change in x approaches 0. Change in y over change in x is equal to, if we take the limit when change in x approaches 0, so if we put 0 here, everything here turns to 0. So you will be left with nx raised by n minus 1. So we can say that dy dx is equal to nx n raised by minus 1. This is equal to this. So we can call this what? The general formula. The general formula, because solving differentiation, even without looking, you can use this method, this formula, to apply it without solving, solving. Just look at the what to differentiate. With this formula, you can just tackle it. So let's use this formula to try this question. I say that let's find the derivative of this. So if we apply this formula that says that, okay, we have to find what? Dy dx. If you use the formula that says that nx is by n minus 1. So what is n? N is 7. So we say that 7 times x raised to the power 7 minus 1. So 7 minus 1 is what? So we have what? 7x. 7 minus 1 is equal to 6. So this is what? The derivative of x raised to the power 7 is what? 7x raised to the power 6. So let's answer the next question that says that 3, the cube root of x cube. Find the derivative of the cube root of x square. So this can also be written as x raised to the power 2 over 3. X raised to the power 2 over 3. So now, if we apply this formula that says, and the general formula that says nx raised to the power n minus 1, so we can say that this is equal to 2 over 3 times x raised to the power 2 over 3 minus 1. So 2 over 3 minus 1 2 over 3 minus 1 is equal to minus 1 over 3. So we are left with 2 over 3 times x raised to the power what? Minus 1 over 3. So this is equal to x raised to the power minus 1 over 3 is still the same thing as, this is still the same thing as 1 over the cube root of what? X. 1 over the cube root of x. So this, we say 2 times 2 over 3 times 1 over the cube root of what? X. This will give us what? 2 over 3 times the cube root of x. So this is the derivative of 3 root x raised to the power 2. So our answer is what? 2 over 3 times the cube root of what? You can also enclose it in a bracket. The cube root of x. So on our next class, we are going to talk about sum rule, quotient rule, product rule, and different rules of on how to evaluate or how to find derivative of what a function. So please like, share, and subscribe. See you on our next class.